All right, in this video, we're going to be looking at if the vertex is on the outside of the circle. And so we have three different examples here to look at of how this may be drawn. So you can see that in each one of these, the angle, if we look here, is marked in blue. And then to find the angle, we take 1/2 of the difference of the two arcs. So to find this angle here, it's going to be 1/2 of this arc minus this arc. To find this angle here, it's going to be 1/2 of this arc minus this arc. And then to find this angle here, it is going to be 1/2 of this arc minus this arc. So now I need you to go to your foldable, and we are going to look for the foldable, that's the part of the foldable where it says the vertex is on the outside, and we're going to go through some practice problems here. So if we take a look at letter A, we are looking for this angle here, and this one's pretty straightforward. We're looking for this angle. And so that is going to be 1/2 of this arc, which is 110, minus this arc, which is 49. And that's going to give us 30.5 degrees. Now, if we look at letter B, we're once again looking for this angle right here. And what we can do is we can actually look at this problem a couple of different ways. And as you start to get better, you'll start to see more connections. So if we were to take and to draw in this radius right here, what we might see is that you might actually find out that what we have is a triangle there, a right triangle, and if we use triangle sum, this would be 90 degrees here, and this would be 56 degrees here, and this would have to be then 34 degrees. So if you saw the triangle, you could use triangle sum. If not, what we could do is that if this arc here is 56, then after drawing this in, this central angle would be 56. We would then know this angle of 56 plus this angle here that was unknown make up 180 degrees. So 180 minus 56 would give us that this angle is 24. That would then 124, which would be a central angle, and therefore this arc would be 124. And then you could use the formula that x, this angle here, is equal to 1/2 this arc here, 124, minus 56. And you would still get 34 degrees. So it kind of depends on what you see in that problem. Looking at letter C, letter C is also one that you might be able to see two different ways to be able to do the problem. So if we look at this, here's the x we're looking for. If we look at this, if this is 125, and I know that the whole thing is 360, then this must be 235. And so I could use the formula that to find the angle x, we're going to have 1/2 of this one here, which is 235, minus this arc here, which is 125, which gives us 55. Now, what we could do is once I drew these in here, what I have is a quadrilateral. And if I drew these in, I would know that these are right angles. And if this arc was 125, then this central angle would have to be 125. And I know that the whole quadrilateral has to be 360. So if I would take 360 minus 90, minus 90, minus 125, that would give me the 55 degrees also. So there's an alternative way to do letter C as well. All right, going up and looking at letter D, you can see that the difference between the first three examples that we did, we were looking for that angle. When we look at these three examples, the vertex is still on the outside, but we're given the angle, and what we're looking for is one of the arcs. So if we look at this letter D here, if we follow our formula that the angle, 50, is equal to 1/2 of the difference of these two arcs. So I'm going to take this 114 and I'm going to subtract out x. And so what happens, I'm going to take and multiply by the reciprocal. That's going to make that 50 100. And then when I solve for x, I'm going to have 14 degrees for this arc here. So we can use this formula not just to find the measure of the, or find the angle, but also to find that measure of the arc. Okay. All right, if we look at the next one here, once again, it all depends on how you see and approach the problem. If I look at this, I would take and draw from point B to the center of the circle and draw in that radius, and that would make this a 90-degree angle. So I could get this answer just by using triangle sum. If this whole thing is 180 of the interior angles, then 180 minus the 90 minus this 36 would leave us with this would have to be 54. So I could do this problem without even looking at the new formula. If I don't see that, what I could do is this. If I take and look at my angles here, I could say that if I knew that this angle here was x, unknown, then I would know that this here would be 180 minus x. So I kind of put a highlight over top of it. This is my unknown. I know that this whole thing here is 180. And if this part is x, this part would have to be 180 minus x. And so I say that the angle is equal to 1/2 the difference of the arcs. This arc is x. This arc is 180 minus x. Once again, because together they form 180 degrees semicircle. And so I take multiply by the 1/2 to get the 72. I am going to have to do the distributive property here. And when I solve that, I'm going to get 126. Sorry, 126. So once again, you could have used that triangle sum to figure out that this angle was 54. If this angle is 54, this one has to be 126 to form the 180. And if this is 126 as a central angle, then this arc has to be 126 also. Okay. All right, so let's look at letter F. We are looking for this x right here. And so one thing that we could do is if we were to take and draw in, and if we have this radius here and this radius here, we know that this is 90 degrees and this is 90 degrees. But if you look at this, we have a quadrilateral. So if I were to take 360 and subtract 52 and subtract 90 and subtract 90, that would give me 128. And if 128 is a central angle, then this arc here is 128. So I could do that without using the formula. But let's look at how we could use the formula to do that in case you wouldn't see that application. So here is 52 equals 1/2. And if we go to look at this, we know that this is x and that all the way around is 360. So this part here must be 360 minus x. And since it's the larger part, we're going to go first. So this is going to be 360 minus x, and then minus our x over here. So I'm going to take and multiply by a half. That's going to give this 104. If I look at this minus x and minus x are going to combine to give me a negative 2x. And so I'm going to solve this to get that x is 128. So once again, we could have gotten, like we said at the beginning, that answer of 128 just by knowing the properties of that quadrilateral and knowing that they would have to all add up to 360. We could find the central angle is 128. Then we would have to know that the central angle and this arc would be the same. So as you go through these problems, you may see more than one way of approaching the problem.